All right, so we're going to look at 7-1, ratios and proportions. So as I said before, this should be a review, most of it for you. So let's look at the review portion. You can write a ratio in 3 different ways. You can either write it with the word 2 as a fraction or with a colon in between. So if we're going to write a ratio to compare 9 red marbles to 16 blue marbles, one way would be 9 to 16, or 9 over 16, or 9 to 16. Those 3 ways. So if they ask you to write your ratio in 3 different ways, those are your 3 different ways. Then in simplest form, and an emphasis on simplest form, you need to write the ratio of vowels to consonants in each word below. How many vowels are there in the U.S. alphabet? A, E, I, O, and U. And I know that sometimes it's Y, but we're not counting Y as a vowel. So there's 5 vowels. So how many consonants would that leave? How many letters in the alphabet? Well, there are 26 letters in the alphabet, 21 consonants, right? So when you look at the word comparison, how many vowels are in the word comparison? There's O, so that's 1, and then A, that's 2, I is 3, and O again is 4. And so we would have, I'm going to put a 4 over here because it's not going to be fully reduced. So we'd have 4 vowels. And notice that they say up here, vowels to consonants. That means your vowels are going to go in the numerator and your consonants are going to go in the denominator. And typically, you'll see me writing ratios as a fraction because it's easier to reduce it when it's in fraction form rather than when it's in, like number 3 is in 2 form and number 4 is in that colon form. So that leaves us with 1, 2, 3, 4, 5, 6 consonants. And what is 4/6 reduced to? So 2/3 is your answer. So that's your in simplest form. And then for the word geometry, how many vowels are there? There's E, O, E, right? So that's 3. I'm going to put the 3 down below. And then how many consonants? G, M, T, R, and Y. So is that 5? 1, 2, 3, 4, 5, 6, 7, 8. Yep. So is that fully reduced? 3/5? Yep. So then your answer is 3 to 5. And then the word ratio. How many vowels? 3. How many consonants? 2. So your vowels are A, I, and O, and your consonants are R and T. And that one's fully reduced as well. And then for number 5, I want you to cross out the ratio that is not equivalent to 12/8. So 12/8, let's write 12/8 over here to the side. What is 12/8 reduced to? What goes into both 12 and 8? 4, right? The highest is 4. And so 12 divided by 4 is 3. 8 divided by 4 is 2. So you're looking for any ratio that reduces to 3/2. Does this reduce to 3/2? 6 to 2? Nope, so that one gets crossed out. What goes into 9 and 6? 3. So 9 divided by 3 is 3. And then 6 divided by 3 is 2. Doesn't that reduce to 3/2? So that's good. What goes into 24 and 16? Biggest number? 8. So 8 goes into 24 3 times, and 8 goes into 16 2 times, so that reduces to 3/2. And then what's the biggest number that goes into 48 and 32? 16. So how many times does 16 go into 48? Best guess? 3. Is 3 times 16 48? Yep. And then what's 32 divided by 16? 2. And so doesn't that also reduced down to 3/2. So the only one that does not is not equivalent to 12/8 is the 6/2. And then you have the new vocabulary word, which shockingly is proportion. So a proportion always includes an equal sign, and so you see that over here to the right. And then they give you some examples of proportions. And so we're going to do example number 6. We're going to write either 3 or 6 to make the proportion true, but I really don't care that we're writing 3 or 6. I want you to figure out how you can figure it out without making it too difficult. First of all, cross products are always equal in proportions. So on this one, if I don't know what that box is, I'm going to let it be x. So I've got 3 times x, that would be 3x, equals 2 times 9 is 18. 3 times what number is going to give you 18? 3 times what number gives you 18? 6. So that means that that number in the box must be 6. So that's one way that you could figure these out. However, on this one, it's quite nice that if you look at, I'm going to sneeze here, banana? No. If you go backwards and you look at the denominator here, so let me see if I can change my color. If you go to the denominator here, and do you see that 3 and that 9 in the bottom? What do you have to do the 9 to get to the 3? Because the 2/3 is my full ratio, and so I don't want to look at that side. I want to look at the side that does not have the full ratio. So what do you do to 9 to get to 3? You divide the 9 by 3. So, or, I'm sorry, what would I do to 3 to get to the 9? I actually said it backwards. I would multiply the 3 by 3 to get to that bottom number of 9. And so what do you multiply 2 by, which is in the numerator? What do you multiply the 2 by? 3. So you would multiply this 2 right here by 3 to get to that 6. So we can apply that over here at this next proportion. So look at the 8. What would you do to the 8? So look at the denominator here. What would you do to the 8 to get to the 4? Divide by 2. So what's 6 divided by 2? 3. Let's look at the cross products and see if they're equal. What is 3? Let's do blue for that one. So what's 3 times 8? 24. And what's 4? Was that a 6? Yeah. What's 4 times 6? 24. Don't my cross products equal? So that means that 3 must be the correct number. So it doesn't matter how you do those. So I want you to do the 1/3 equals 2 over blank, and the 5 over blank equals 10 over 6. See if you can figure out what those are using either of the two methods that we talked about. And then when you get your answers, you can share with those around you. What was that noise? Oh. Okay, so let's look at that third ratio. Shh. Let's look at the third proportion. What do you have to do to the 1 in order to get to the 2? Multiply 1 times 2. So we're going to take the 3 and multiply the 3 by 2. Don't we get 6? Right, in your cross products, 1 times 6 is 6, 2 times 3 is 6. And so my cross products, 6 equals 6. That's actually a 6. Then look at the 10 and the 5 in the last ratio. Look at your 10 and 5, Mr. Ruby. What did you do to 10 to get to 5? Divide by 2. And so 6 divided by 2 is 3. And then our cross products, 5 times 6 is 30, and 3 times 10 is 30. So my cross products are equal. So that should all be a review, true? So on those problems, you're either multiplying or dividing by something to get to the other item. The problem is if you can't multiply or divide by a nice, happy integer, then if that case occurs, you're kind of stuck with looking at this one that we did, looking at this one that we did right here and doing it in that way. In other words, letting that box be the x, making your cross products and solving using the algebra if it's not a nice, happy integer, and we'll come across some of those in a minute. All right, so then we're not going to do 7 and 8. Are there any questions on those? No. It has a lot of gobbledygook in there. A lot of gobbledygook. A lot of extra chatter. And so I want you to focus mostly on this part right here. All that this is telling you is that there are several properties of proportions and that cross products are equal. So you have A times D is AD. And then B times C, they should be equal to each other. And so, let's use so many choices. Let's use green. And so AD should equal BC. And then they apply 3 different properties here. Basically, they're taking each of the proportions, and you can write your proportions in 3 different ways, so long as the cross products are equal. And you'll notice that in all of these proportions, so if you look at property number 1, if I use my cross products, look at the red ones, A times D is equal to, and look at the blue ones, B times C. Aren't those cross products still equal? But this is a different proportion than the proportion above. As long as your cross products are equal, you have set up a true proportion. Look at the property number 2. Look at your red, A times D. Actually, this is the same as the one above, isn't it? Oh, I'm sorry. Look down here. Oh, go away. So look at the one below. All they've done is switch the C and the B around. But are your cross products the same? Look at the red. A times D is equal to C times B. Isn't that the same as what we had to the left? Now, what are they doing in property 3? What's different from here to here? A over B, right? And instead of A over B, what have they added in here? They've added a B up top. And what do they add over here? They added a D. Does that work? Well, let's see. So we end up with, let's do cross products. So we've got D times A, which gives you AD, and D times B, which gives you plus BD, equals, and then multiply your B through B times C, which gives you BC, plus B times D, BD. What's the same on both sides? BD. And so if I subtracted out a BD, won't you be left with AD is equal to BC, which is the same as CB? So they took the denominator and they added it to the numerator. I actually haven't seen that done very often. That's kind of a weird one. And they've added it to the numerator in each one of those, and it created an equivalent proportion. Bailey?
Does it matter what order you put the numbers in?
And it does not matter when you do your cross products. So if we're looking at this one that we did up here, so you could have written it as DA equals CB, or you could have written it as BC equals AD. It doesn't matter what side of the equal sign that you put your cross products on. It won't make any difference. And so on the bottom part here, they want you to identify which statement or which property that we're using. And so you could just name it as property 1, property 2, property 3, or cross products. So look at number 10. What's happening from 3/12 equals 1/4 to 3 over 1 equals 12 over 4. Obviously, that's not cross products, right? So they apply property 1, 2, or 3. Because remember, the 3 and the 1 in the left proportion, so if you're looking at this proportion here, the 3 and the 1 have now gone here, right? So look at your properties 1 and 2. 3 and the 1 refers to A and C. So which one did A and C become A over C? Property 2. So this is just like property 2. So what's happening number 11? 4/5 equals 8/10. You get 4/10 equal, or 5 times 10 equals 5 times 8. What are they using there? Is it property 1, property 2, property 3, or is it cross products? This is the property that you're looking for, the actual ratio, to determine if it's property 1, 2, or 3. They don't have a ratio here, do they? Yes or no? Nope, no ratio there. So isn't that just cross products? All they've done is they've taken 4 times 10 and 5 times 8, and so that's cross products. And then look at number 12. We've gone from 1/3 equals 3/9 to 3 over 1 equals 9 over 3. So do yourself a favor and identify one thing. So look at the 1 and the 3. Haven't the 1 and the 3 switched to 3 over 1? Right? And the 1 and the 3 is the same as A over B. So where did A over B switch to B over A? Was that property 1, property 2, or property 3? Property 1. So this is property 1. And then look at 13 is different. We've got 3/4 equals x over y. And then all of a sudden the 4 stays the same, right? 4 stayed the same and the y stayed the same. But look at what happened. The 3 became 7. What do you do to 3 to make it 7? What do you do to 3 to make it 7? What's the denominator? Didn't they add 4? Isn't that the same as the denominator? Okay. And what did you do? What did they do to the x to make it x plus y? What do you do to x to make it x plus y? You added y. Isn't that the same as the denominator? Wouldn't that be property 3? Where they're taking the denominator of the fraction and adding it to the numerator. And oddly enough, it creates a true proportion. All right, so let's look at problem 1. You won't see me using property 3 that often. So they say a bonsai tree is 18 inches wide and stands 2 feet tall. They want to know what is the ratio of, notice what they're telling you, because your ratio could be length to width to length, I guess height in this case. So look at what they're telling you. They want width to come first, and then 2 is that word that we're looking for because that's part of our ratio to height. So we want width to height. So that's going to be W over H, or W2H, or W:H. So the words in the original problem are going to tell you what ratio to use. And so the bonsai is 18 inches wide. And notice that we go from 2 feet tall to inches tall. When we're comparing inches to feet, that's not a fair comparison, is it? So how are we going to convert 2 feet to inches? How many inches in 1 foot? 12. So that means that I've got 2 feet times 12 inches. What does that equal? 24 inches. So that's where our 24 is going to come from. So we've got 24 inches. So there are 3 ways to write it. Now I'm going to be real picky because 18/24 reduces to what? What's the biggest number that divides into both 18 and 24? 6. So 6 goes into 18 3 times. 6 goes into 24 4 times. Now your book is going to tell you, oh, you're going to write 18 to 24, 18 over 24, and 18:24. I don't like that. You're going to see that as answers. You want to write it in reduced form at all times. And so we've got 3 to 4, 3 divided by 4, and 3:4. So again, that should be a review. Was that a problem? Did I miss something? I want to make sure I didn't miss it on my thing. Was that problem 2? Oh, it's missing problem 2, isn't it? Okay, so I'm not crazy, right?
A little bit.
They have not put problem 2 in there. Fascinating. I didn't notice that last night. Okay, so then problem 3. You've got the lengths of the sides of a triangle are in the extended ratio of, this is really important, the ratio that they give you, 4, 7, and 9. I don't know what the lengths of the sides of that triangle are, but they're always in the ratio of 4, 7, and 9. Now, I don't necessarily like how they're, I like how they're doing it, but I want to explain to you why. The other thing that they gave us is that perimeter is 60 centimeters. If you, how do you find perimeter of a triangle? Add up all the sides. So if I add up 4, 7, and 9, what do I get? What's 4 plus 7? 11. 11 plus 9, 20. Is that 60? No. So then my next ratio, if 4 to 7 to 9 didn't work to get me, because that added to give me 20. So then we're going to go in these same ratios again. So the next multiple of 4 would be what? 4 times 2 is what? 8. 7 times 2 is what? 14. 9 times 2 is 18. So what is, it's probably easier to add 14 and 18. What's 14 and 18? 32 plus 8? 40. Well, that's not it. I mean, I could keep doing this all day long. I propose that what's going to happen the next time. Yeah, so then take 4, multiply it by 3. 4 times 3 is 12. 7 times 3 is 21. 9 times 3 is 27. What is 21 and 27? 48 plus 12? 60. Isn't that what I'm looking for? Well, I don't want to do that every time. How many multiples was that? 3 multiples. Notice that I multiplied every number by 3 in order to get that. So whatever the multiple is, I'm going to multiply every number in that ratio by that multiple. So my point being, if you don't know how many multiples there are, you let x be what you're multiplying to each of those numbers, because I don't know what I'm going to multiply to the 4, the 7, and the 9, but I do know that I'm going to multiply all 3 of them by the same number. And so we always attach an x onto each of the numbers in that ratio. And then we use the other information in the problem to figure out how to solve it. So because they gave us perimeter, we added up all the sides. And so over here, you can see them applying that. And so we're going to take that 4x plus 7x plus the 9x and set that equal to 60. And in the long run, that should be a lot quicker to come to your answer than what we did over here on the right. And so if I add 4x, 7x, and 9x, don't I get 20x? And if I take that 20x, which is equal to 60, and divide by 20 to solve, doesn't x equal 3? And isn't that what we came up with here? But what that doesn't do is the question says, what are the lengths of the sides? Solving for x, does that answer the question? Nope. So then we need to plug in 3 to those sides, and we've actually already done it over here, but that's because we did it the long way, right? So if I multiply 4 times 3, I get that 12. If I multiply 7 times 3, oh, wait a minute, that should be an x, shouldn't it? So if I multiply 7 times x, and my x is a 3, I get my 21. And if I multiply 9x, my 9, and then my x is a 3, we get that 27. And so the lengths of the sides are 12 centimeters, 21 centimeters, go away, and 27 centimeters. You can have a lot of those. That's a very popular style question. Issues, problems, or concerns with that. Okay. And then problem 4. What is the solution of the proportion 9/2 equals a over 14? So look at your full proportion side, which is this side right here. What do you do to 2 to get to that 14? Multiply by 7, so then we can just multiply 9 times 7, because we're multiplying top and bottom by 7. And what's 9 times 7? What's 9 times 7? 63. But they want you to use your algebra. So remember, I told you that that was the other way to do it. Typically, I'll use my algebra to solve anyway. And so what are they doing from step 1 to step 2? So this is your given. We're going to look at it like it's a little proof. That's your given. And then from step 1 to step 2, what did they do? How did they break apart that proportion? They use cross products. And then how they go from 9 times 14 to 126? They just multiplied, right? Or wasn't this substitution? If you want to do it in true proof format. And then what are they doing from here to here? What are they doing to both sides? So this is your division property of equality. And then finally, they actually did 2 things here, didn't they? They did 2 properties. What do they do? How'd they go? First of all, they went from the left to the right, didn't they? The 2a over 2 became a, but that went over to the left side. What property is it when we flip sides? Remember? What is it? The reflexive property. And then they actually divided both sides, right? So not only do we have, the first thing that they did was substitution. And then they did the reflexive property. All right, so I'm going to stop there, but we're going to go to your workbook and work some problems. And so look at your workbook. Look at page 183. Is it 183? Yeah, 183. And I want you to look at number 7. Number 7 says the ratio of country albums to jazz albums. So we have country to jazz. How did I know that country went up top?
Because it was listed first.
That's exactly right. So whatever comes first goes up top. And I'm looking for that word too. So country to jazz. Country went up top, jazz went on the bottom. Is 2 to 3. So it's equal to 2 to 3. If the music collection has 45 albums, so we've got 45 albums, how many are country albums? How are we going to figure that out? Well, I'm interested in country albums, so notice that, look at what they've given you. They've given you 45 albums total albums, and then country. Can we set up a ratio that is country to total? Can we set that up? Well, notice here that if we had 2 country records and 3 jazz records, how many total records would that be? So the total here equals 5. Our total for our records is 45. The reduced total is 5. So couldn't we put 5 here for our ratio total, but our country is 2. So that's a little bit more difficult than what we were looking at earlier. And do I know country or total on the left side of this proportion? What did they give me? They gave me total, right? So I know that this is 45. So I can replace the country with X and just solve using algebra. Or I could, what do you do to 5 to get to 45? You could do that as well. You can multiply 5 by something to get that 45. I find it just as easy just to do your algebra. So x times 5 is 5x equals 2 times 45. So you've got 5x is equal to 90. Divide by 5. And then x is equal to what? 5 goes into 9 once. What's left over? Yeah, and then, so that's a 4. And then 5 goes into 40 8 times. So what does x represent? What do we let x represent? Country albums. Does that answer the question? Yeah, it does. So therefore, triangle dots, therefore, there are 18 country albums. Then let's look at number 10. Whoops. So let's finish up our notes for 7-1. And so quiet. We should be at problem 5. Ian, if you need the notes, I have them here. Right up here. So problem 5 says use the proportion x over 6. So you're going to use this proportion x over 6 equals y over 7. You like my lightsaber? The nerdy things that math teachers enjoy. What ratio completes the equivalent proportion 6 over x equals blank over blank? So you've got to look at your cross products. And so the cross products here, if I multiply x times 7, I would get 7x, wouldn't I? And then if I multiplied 6 times y, I would get 6y. Agreed? And shouldn't they be equal? So they want to know what ratio, and notice that they've changed. How have they changed this ratio right here, over here? What have they done here that they did here? They flipped it. So instead of the 6 being on the bottom, the 6 is now on the top. So what should they do to this one here? Flip it as well. So the 7 needs to go up top and the y on the bottom. So instead, we're going to take over here and put the 7 up top and the y on the bottom. And for number 23, I'm not going to ask you that. To me, it's a little bit more confusing. Well, which one does it match? I will never ask you that on a test. So suffice it to say that 7 over y should be our proper ratio. Now, how can I check that to make sure that's correct? Cross multiply. So I'm going to take my 6 times my y right here, and I get 6y equals, and then I'm going to take my x times my 7 right here, and I get 7x. Even though they're backwards, is this exactly the same as this? Yeah. So they do give equivalent cross products, and that's what I'm looking for there. And then the last part is your lesson check. And so I want you to complete that to see if you understand where they made their mistake. So what's the error in the solution of the proportion at the right? Oh, we didn't talk about means and extremes. If you go back and look all the way at look at the first page of your notes. Was it on your first page of your notes? I could swear it was. Oh, maybe they didn't show it in your notes. Oh, maybe it's because... Oh, yeah, there it is. So look at, there you go. So second page of your notes, which is under the means and extremes. I honestly am not going to ask you that because I really don't care. The means and extremes deal with your cross products. So here, when they're looking at this ratio, or I'm sorry, this proportion right here, your means and extremes are either going to be the 7 and the x or the 3 and the 4. For our purposes in this class, it really isn't important for you, in my opinion, for you to know what's a mean versus an extreme. So we're not going to go over that, so ignore that part. So 25, circle the, so skip 25. Sorry, so skip 25. And then write your products, because those are your cross products. So go ahead and do 26, answer 27, and now solve that proportion correctly. All right, so what are your cross products? So if I took 7 and multiplied it by x, I would get a 7x, agreed? And then your other cross product would be 3 and 4 multiplied gives you 12. So what did they do wrong? Yeah, they didn't use cross products, did they? So these right here, the 28 and the 3x, didn't they multiply horizontally? They multiplied the 7 and the 4 together, and they multiplied the 3 and the x together. So that would be horizontal products, which we don't use to solve proportions. So they wanted to do their cross product, or they should have done their cross products, and so everything else is wrong. So the error would be they didn't use cross products. So set your cross products, which is 7x, equal to the 12th. Then what do you do? Divide by 7, and then what does x equal? Is that fully reduced? Yep. So do not change it into a mixed number. Absolutely not. There's your answer. 12 sevenths. So let's go move to your workbook. So we're going to look at your workbook, which is again page 183. Oh, hang on. 40. What do you propose you should do first? How do you break apart a proportion, first of all? That's a 2. Hard to tell, but that's a 2. How do you break apart a proportion? I can't multiply or divide 16 or 40 by anything to get x or 2x plus 1. So what's your only option? Cross multiply, right? But look at the 16 and the 40. Can you simplify 16 and 40? What's the biggest number that goes into both 16 and 40? 8. So 8 goes into 16 2 times, and 8 goes into 40 5 times. So I would be using those numbers when I cross multiply. So when I cross multiply, I'm going to take the x times the 5 and the 2x plus 1 times the 2, but be really, really careful. So I'm going to take x times 5 equals 2 times 2x plus 1. Make sure that you're fully distributing this 2 into the entire parentheses. And so we end up with x times 5 is 5x equals, that was an equal sign, equals 2 times 2x is 4x, 2 times 1 is 2. Then how do you solve? Subtract what? So subtract 4x from both sides, and I end up with x equaling 2. And then you can check that and make sure that that does give you a true proportion. So if I plug 2 in up top, and this is just a check, and I would only check it if I were taking a test. And so I'm going to put 2 in up top. I want to see, does that equal 2 over 5? So I get 2. What's 2 times 2? Plus 1? 5. Does 2/5 equal 2/5? Then that's a check. Check. So you do want to just double check that. So your answer, x is equal to 2. And that's all that they were looking for that one. Then I want you to look at 14. And I want you to solve 14 on your own. So 14 is 3 over 34 equals m over 51. There is nothing that you can multiply 34 by to get 51, is there? So what's your only option? Cross products. So solve it using cross products. When you get an answer, I want you to share it with those around you. When you get an answer, share. When you come down to the final answer, 153 is not a number that you're normally familiar with. The 34 is a smaller number. What numbers divide into 34? 2 and 17. So those are the only possible two numbers that could go into 153. Does 2 go into 153? Nope. But try 17. Is there anything that you can multiply 17 by to get to 153? 8? Bless you. So if I took 17 and multiplied it by 8, no, 8 times 7 is what? 56. That's not a 3. And so 9? 9 times 7 is what? 63. And 9 times 1 is 9 plus 6. So 17 times 9. So that means that 17 goes into 34 how many times? Twice. And 17 goes in 153 9 times. So your fully reduced answer is 9/2. So that one's a little bit more difficult. You can't use a guess and check kind of method. You have to use cross products. On a new page. So again, it's page 183 of your workbook. But today I want you to look at question 19. Question 19. It says the measure of two consecutive angles in a parallelogram. So the first thing you should do is what? Draw a parallelogram, right? What would be consecutive angles? What does that mean? They're what? Well, that's what they are, but I mean that's what they add up to. But how do I know which angles are consecutive? Are these consecutive here? Yeah. How about these here? Yes. How about these here? No. So they have to be one right after the other. So you choose in your parallelogram where you want to put them, but your consecutive angles are in the ratio of 4 to 11. So I'm going to choose these two angles here. Do I put 4 and 11? Do I put just 4 and 11? Is that the measure of my angles? No, what? I have to add an x to it, right? So 4x and 11x. And then, Olivia, what did you say about those? That those angles here, these are supplementary. So the connection that you had to make was that I've got consecutive angles inside a parallelogram. They are always supplementary. So we're going to take those angles, 4x plus 11x, and set them equal to 180. So you solve from there. And the question is asking you, what are the measures of the 4 angles of the parallelogram? So when you solve, you have to ask yourself, did you answer the question? Ian, are you done? You're supposed to be solving. So solve the problem up there. You're finding the value of x, and then you're going to use that to find all 4 angle measures. Bless you. What value did you get for x?
12.
Did everybody get 12? Is that the answer to the question? No. So if I put 12 in for x, so I've got 4 times, instead of x, I'm putting in 12. So what does that equal? 48. So one of those angles is 48 degrees. And then if I put in 12 into the other angle, what's 11 times 12? Do you remember your trick? When you multiply them by 11, so I'm multiplying by 11, take the other number and split it. So take that 12 and split it, and then add the 1 and the 2 together. What do you get? 3. So it's 132. Sometimes there's some carrying that you have to do. So if I have to carry, I usually won't do it. It's more effort. So then that's 132 degrees. What are the other two angles? What do you know about opposite angles in a parallelogram? They're equal. So if this angle right here is 48, this angle is 48. If this angle here is 132, that angle there is 132. So therefore, whoops, it'd be nice if I had my pen going. Therefore, the measure of all 4 angles is 48 degrees, 132 degrees, 48 degrees, and 132 degrees. Then I want you to flip the page. Yes? Is that supposed to be what? Oh, that's the 3 dots is therefore, dot, dot. This right here? That right there is therefore. Have you not seen that before? You've seen me use that before. Okay, so then do a new problem. So flip the page. I would like you to do, bless you, bless you again, number 26. And how's about to do. And then 29. Do those on your own. So while you're doing it on your own, I'm covering up my work. Well, what's the coinky-dink of that occurring? Yes, but that's not the question. The question for 26 says, what is the measure of the larger angle? Right? So I, of course, would choose a problem that was exactly like what we just did. But if you had supplementary angles that are in the ratio of 4 to 11, wouldn't you take 4x plus 11x instead equal to 180 degrees? Which, again, gives us that 15x equals 180. Divide by 15, you get x is equal to 12. Well, won't the 11x be the larger angle? So we already know that's 132. So therefore, the larger angle is 132 degrees. Now do 29. Be careful with 29. When you get an answer, share with those around you. What did we get?
6.
Did you all get 6? It's what? Here's the issue with using the big numbers 10 and 14. What could you have done with the 10 and 14? If I were you, I would have reduced them, because you cause a situation where you're having to multiply by bigger numbers. Now, fortunately on this one, you've only got an x and a 1 that you're multiplying to, so it's not like you're multiplying to big numbers. However, if I can reduce, I will. So I did reduce the 10 and the 14 here, and I got 5/7. So instead, I'm distributing the 7 and the 5. Make sure you distribute it all the way through both parentheses. So in other words, here you should have a number other than 1, and here you should have a number other than 1. I happen to have -7 and 5 because those are the numbers I used. If you didn't reduce, you would have -10 here and +14 here, right? And then no matter how you did it, we still should have come down to x equals 6. How could you check your answer? Plug it back in. So if I put 6 in here, what do I get? Plug 6 back in here, what do I get? 5. Isn't that equal that right there? Plug 6 back in here, what do you get? And it equals that right there. All right? Done.